Okay, so here is vertical problem issues number 2. And we've got this third problem right here where, hold on, there we go. This problem right here where we've got a ball tossed straight up in the air, is in the air for 2.53 seconds. What is the initial velocity of the ball? So here's the issue. When you draw a little sketch here, it's going to go up and turn around and come right back down. So the initial velocity, we don't know. The other thing is we don't know the final velocity. We do know the acceleration, and we do know the time that it's in the air, but that's all we know. So if we take a look at what our givens are here, we don't know our initial velocity. That's what they're asking for. The acceleration is going to be negative 9.8. The time they give us as 2.53 seconds. And that's all we really know. Now, you could also go, well, do we know a displacement? The answer is no, we don't. Because if I catch it the same place where I toss it, it's 0. So it's not really useful to us, and we're not going to actually be able to use it for anything at this point. So what we've got to do here is we've actually got to think a little bit and be like, okay, what can we do with this information? Well, imagine we, divide that trip in half. So we have a trip to the apex and a trip from the apex. If we consider this, we know some more information. We now know that if we're going to the apex, so let me erase all this stuff. If we're going to the apex, we still don't know the final velocity, but we do now know we don't know the initial velocity, but we do know the final velocity is 0 meters per second. Now, the time is not obviously going to be 2.53 seconds because that's for the trip up and the trip down. But here's something that we have to realize. On the trip up and the trip down, we have the same displacement. Well, not the same displacement in terms of which direction they're going, but the same distance. They go the same distance. So if a ball is traveling with the same distance and the same time, in the same acceleration, it will take the same amount of time. So actually, what we can use here is we can use this number here to find the time to the apex as 1/2 the total time in air, because it's half of the trip. So the time to apex is actually going to be whatever that is cut in half. That looks like it's 1.265 seconds in half. Now, if I take a look here, I've got plenty of information to solve this. So if I wanted to, now I would just use this equation here. Vf equals V naught plus AT. And this time Vf is 0. So 0 equals my V naught plus a negative 9.8 times the time, which is 1.265. Now, if I punch that into the calculator real quick, we get 12.4. Initial velocity of 12.4 meters per second. Now, you could also, and I'm not going to do it on this video just for lack of space and time, you could also solve for the trip down, where the velocity at the apex, that your initial velocity would be 0, and then your final velocity would be what you would catch it with. Believe it or not, you would actually get at 12.4 meters per second, but you would get a negative 12.4 meters per second. So what's interesting here is the initial and final velocity ends up having the same magnitude, but a different direction. Now, let's take a look down at the second part here, if we can get it to scroll down. All right. There we go. Get the block that off a little bit. So the next question is, how high did the ball rise? Well, now that we know the initial velocity, we can use that as part of what we're doing. We know the time. We can solve for that pretty easily. So the equation I'm going to use here is just this one. Displacement equals V naught T plus 1/2 AT squared. Nothing goes away. Nothing will cancel here because I don't have any zeros. So this will be 12.4 times my time, which is 1.265, plus 1/2 times negative 9.8, and times the 1.265 squared. So let me run that through the calculator real quick, and I get this part right here ends up being 15.686 minus whatever this comes out to be. So hold on, sorry, let's go back. I don't know why it decided to do that. Anyways, let me erase this real quick. This whole thing comes out to be, this whole equation turns into 7.84 meters. There we go. And we'll circle that one. So there are vertical issues. Like I said before, the vertical issue vertical issue number 3 is that you can take the total time in air on a ball that's tossed. This does not work for a ball that's dropped, but for a ball that's tossed